In examples 4 and 5 from Notes 5.1 Day 1, Exponential Functions and Their Graphs, we're exploring what happens when we change the magnitude of b in our standard exponential function y equals a times b to the x. So we're just going to focus on b for now. We talked about earlier that if b is greater than 1, we have exponential growth. Because we're multiplying by a number larger than 1, the function is going to continue to grow as x gets larger and larger. So now we're going to graph 3 different growth functions. We're going to graph 2 to the x, 3 to the x, and 4 to the x. So I'm going to plot some points on the first function, 2 to the x. I'm going to do those in blue. So when x is 0, 2 to the 0th is 1. When x is 1, 2 to the first is 2. When x is 2, 2 squared is 4. When x is 3, 2 cubed is 8. And I can't put any higher values of x on my graph. If x is negative 1, 2 to the negative 1 is 1/2. And if x is negative 2, 2 to the negative 2 is 1/4. So I'm going to sketch y equals 2 to the x, or f of x equals 2 to the x, something like that. I'm going to graph 3 to the x. So once again, if x is 0, y is 1. So it goes through that same point. When x is 1, y is 3. When x is 2, y is 9. And when x is negative 1, y is negative 1/3. So, positive 1/3. So it's actually a little bit beneath the function 2 to the x when x is less than 0, and then it's going to be steeper. Let me fix that a little bit. It's going to be steeper when x is greater than 0. So it's going to be something like that. And then 4 to the x. So when x is 0, y is 1 on 4 to the x. When x is 1, y is 4. When x is 2, y is 16, so a little bit 1 unit above the top of the graph. And when x is negative 1, y is 1/4, so it's going to be a little bit closer to the x-axis. And then when x is less than 0 and steeper when x is greater than 0. So this one is 2 to the x, 3 to the x, and 4 to the x. And based on these functions, we can generalize a bit. So we can say that if b is greater than 1, we have growth. And we're going to say that the graph, if x is greater than 0, the higher b is, the steeper the graph. And that makes sense because we're multiplying by a larger value. The closer, let's see, when x is less than 0, the higher b is, the closer the graph is to the y-axis. Or I'm sorry, to the x-axis. And the third thing that we can say is that all the graphs pass through 0, 1, so they have the same y-intercept. Okay, so that's a summary when we have growth. Now we're going to go on to example 5. In example 5, we're going to explore 3 functions when we have decay. So here, our b value is between 0 and 1. That's when we have exponential decay, because we're multiplying by a number like 1/2 over and over and over. The values are going to get smaller as we continue. So we're going to graph these 3 functions. F of x equals 1/2 to the x. So I'm going to sketch this function. So if x is 0, y is 1. When x is 1, y is 1/2. When x is 2, y is 1/4. When x is negative 1, I have 1/2 to the negative 1, which is 2. When x is negative 2, I have 1/2 to the negative 2nd, which is 4. When x is negative 3, I have 1/2 to the negative 3rd, which is 8. When x is negative 4, I would actually be up at That would be 1/2 to the negative fourth, which is 2 to the fourth, which is 16. And as we talked about earlier, this graph is actually just the reflection of 2 to the x in the y-axis, right? Because 1/2 to the x is the same thing as 2 to the negative x. Okay, so this is y equals 1/2 to the x. Then we're going to go ahead, we're going to graph 1/3 to the x. So I'll get some points on this graph as well. When x is 0, y is 1. When x is 1, y is 1/3, so it should be a little bit beneath it. When x is 2, y is 1/9. When x is -1, y is 3. When x is -2, y is 9. So I'm going to sketch this graph. It's when x is greater than 0, this graph is closer to the x-axis than 1/2 to the x, and then it's going to be steeper when x is less than 0. So this is y equals 1/3 to the x, and let's graph the last one. F of x equals 1/4 to the x. So when x is 0, y is 1. When x is -1, y is 4. When x is -2, y is way up here at 16. When x is 1, y is 1/4. When x is 2, y is 1/16. And I'm going to go ahead and sketch this graph. So this is y equals 1/4 to the x. All right, we're going to make some general conclusions just like we did in example 4. So the first thing that we're going to conclude is these graphs are the reflections in the y-axis of the graphs in example 4, right? Because 1/2 to the x is the same thing as the 2 to the negative x, which means that 1/2 to the x is the reflection of the graph of 2 to the x in the y-axis. The same thing holds for the other two graphs. And then the other conclusions we're going to talk about is what happens to the graph as we change b. So I'm going to write those down here. Slide up a little bit. So what we conclude is, so when we have decay, so if b is between 0 and 1, then if for x less than 0, the steeper the graph for b closer to 0. So the closer b is to 0, the steeper the graph. For x greater than 0, the closer, when x is greater than 0, let me say that better. When x is greater than 0, the closer b is to 0, the closer the graph is to the x-axis. And the third conclusion, when a is 1, which it is on all of these, they all graphs pass through 0, 1. This is because that a value is 1, regardless of what b is. Last page. So on these, what I would recommend doing is find the parent function and then the graph of the parent function, and then each one of the other graphs is some sort of transformation. So in looking at these equations, 2 to the x we can think of as our parent function. We've graphed that a bunch of times. That graph is going to go through 0, 1 and 1, 2, and it's going to be growth because the base, b, is greater than 1. So I'm going to look for a growth function that passes through 0, 1 and 1, 2, and that looks like it will be h. So the parent function is h. And then we're going to look at the other ones and see how they're transformed. Number 2, if you have y equals 1 to the x, that's simply 1. So this is the horizontal line at y equals 1, and that graph is e. So that's not even an exponential function. Number 3, we have 2 to the x plus 2. The plus 2 means this is shifted up 2 relative to the graph in h, which is the parent function. So I'm going to write down this is like our parent. So if we take that graph and it goes up 2, instead of going through 0, 1, it should go through 0, 3. And then instead of having a horizontal asymptote at y equals 0, it should have a horizontal asymptote at y equals 2. And if I look at these graphs, this graph looks like it has a horizontal asymptote at y equals 2, and it looks like it goes through 0, 3. It'd be up 2. So I would say that number 3 is F. The next graph, we have 2 to the x minus 2. The minus 2 means it's going down 2 relative to the parent. So if a graph is going down 2 relative our parent function, this is our parent function here, then it should, instead of through 0, 1, it should go through 0, negative 1, still being growth. And if I look at my graphs, the only one that goes through 0, negative 1 is G. Okay, number 5. Over here, the negative in front, this means it's a reflection in the x-axis. So if I look at the parent function in H, and I reflect that over the x-axis, it should be going through 0, negative 1, and then be reflected, and that looks to me like C. Number 6, the 2 out in front, that's a vertical stretch by a factor of 2. Okay, and that's going to multiply all y values by 2. So instead of going through 0, 1, it should be going through 0, 2, and it's still going to be growth, but it's going to be a little bit steeper because of that vertical stretch. So if I look at my remaining graphs, I have A, B, D, and that's it, just A, B, and D. This has to be A because this is going through 0, 2, and it's a little growing faster than the parent function. The next one, when we've got 2 to the x minus 2, this is going right 2. So if our original parent function went through 0, 1, if it's going right 2, it should be going through 2, 1. So number 7 is D. And number 8, when we have x plus 2 in the exponent, this is going left 2. So the parent function went through 0, 1. This one should be going through negative 2, 1. So this is B. Okay, beneath the graphs, we have one more question, and that's to think about the graph of y equals 2 to the x minus 2, which is actually the graph that we made in number 4 up above. And if we think about this graph, this is shifted down 2 relative to the parent, which is y is 2 to the x. So if we shift the graph down 2, it does nothing to the domain. The domain of these exponential functions is negative infinity to infinity. However, the range changes, right? The range used to be 0 to infinity, and if this is going down 2, the range is now negative 2 to infinity, and the asymptote is shifted down from y equals 0 to y equals negative 2. And the only thing that's going to change the horizontal asymptotes for these exponential growth and decay functions will be vertical shifts.